Hello and welcome back to physics class. Today we are going to be talking about acceleration. Now, acceleration is the change in velocity with respect to time. So this means that your object is either speeding up or slowing down. When we describe it using a formula, we would describe it like this. A for acceleration is equal to your change, delta, in velocity over your time. Now, the units for acceleration are often written as meters per second squared, but they can also be kilometers per hour squared. The key is that your time is squared. Now, this is your basic formula for acceleration. However, there are a couple of other formulas that are extremely useful when trying to solve acceleration problems. The first one is velocity is equal to v naught plus acceleration delta t. So here I'm just going to write my legend right here. V is your final velocity. V naught is your initial velocity. A is our acceleration. And of course, delta t is our time. So this is our first formula. The second formula is delta x is equal to delta t times v naught plus v divided by 2. So delta x, if we remember, that is our displacement, our change in position. The third formula is also starting with delta x, but this time it's delta x is equal to v naught delta t plus a delta t squared divided by 2. And the last formula that we'll be using is v squared is equal to v naught squared plus 2a delta x. So these are the 5 basic formulas that we're going to be using. This is just the standard one for when you have a very straightforward acceleration question, and these ones are more specific when you're looking for things such as your displacement or a specific velocity from that problem. So let's take a look at an example. Here we have a cyclist accelerates from rest to a velocity of 10 meters per second in 12 seconds with the constant acceleration. What is their acceleration? Now, when you are analyzing a word problem that involves acceleration, there are a couple of things that you should take into consideration. I personally like to start by drawing a diagram because it helps me visualize the problem. So I'm going to just draw a person on a bicycle. And I'm going to say that they are slowly speeding up. So I'm going to keep drawing bigger and bigger arrows to indicate that they're speeding up. Now, their final velocity at the end is 10 meters per second, and the total time it takes is 12 seconds. Now, if they start at rest, then we know that their initial velocity, v naught, should be 0 meters per second because they started from rest. Rest indicates that you're not moving. So really, this is how I would like to approach my problem, is I draw a diagram and then I put in the variables that I am aware of. So now I want to find out what is their acceleration. So that is my big question. this is where I'm going to take a look at my formulas on this side of the equation here. This is where I'm going to go ahead and take a look at my equations. Is there an equation that I can use to accurately find out what my acceleration is? And yeah, as it turns out, I can. I can use this basic one right here. So acceleration is equal to delta v over delta t. Delta v is your change in velocity, in which case I started from 0 and I went up to 10. So my change in velocity was 10 meters per second. And my time is 12 seconds. So then when I go to calculate my acceleration, I just do 10 divided by 12, and I would get 0.83. Now remember, the units are meters per second squared. And that is how I would solve this problem. Now, what if I wanted to ask a different question? Instead of acceleration, what if I wanted to find the displacement? Well, I would do the same thing. I would draw out a picture, write down all the information I have, and since this is the same problem as before, I know that my acceleration is 0.83 meters per second squared. From here, I would want to take a look at my formulas to figure out which one of these would I want to use to find my displacement. So the first one that we have up here obviously doesn't have delta x in it, so we can't use that one. We could use this one here, which has delta x, and it has our delta t, it has our initial velocity, and it has our final velocity. So we could use this one. We could use the third one as well because it has our initial velocity, our time, and our acceleration. And we could also use the last one here. However, we would have to do a little bit of manipulation to isolate delta x. Out of these three, number 3 is actually the easiest to work with, and I'll show you why. So delta x is equal to v naught delta t plus a delta t squared over 2. V naught, as we see, is actually 0. So when you take v naught multiplied by time, we would still get 0. So this whole thing right here can be crossed out because we know it goes to 0. So we can rewrite this as delta x is equal to acceleration times your delta t squared divided by 2. So 0.83 meters per second squared times 12 seconds squared divided by 2 will give us a displacement of 59.8 meters. Here is a different example. I want you to take a minute and pause this video and try it out yourself. All right, so I hope that you tried it out yourself. Now we're going to take a look at the example solution. So let's start by drawing a diagram. I'm going to draw my car. And there is a red light. And we know that the red light is 40 meters away. So that's my delta x. And we know that the car is coming to a stop. It's braking. So it starts off going fast and then it kind of slows down until it reaches a stop. So I'm drawing my arrows from bigger to smaller to indicate that it's slowing down. Now, we know that the time it takes for it to stop is 3 seconds. And we also know, because it stopped at the end, we know that your velocity is 0 meters per second. Now, the question is asking, what is your v naught? What is your initial velocity in this case? Well, now we need to take a look at our formulas. So let's take a look. We have delta x, we have delta t, we have v, but we do not know what our acceleration is. So we can't use the first one because we don't have acceleration. We could maybe use the second one. We cannot use the third one, and we cannot use the fourth one because they both have acceleration. So we have to use formula number 2. So delta x is equal to delta t is times v naught plus v divided by 2. So I'm going to put in my numbers here. So I have 40 here, and then my delta t is 3 seconds. And I'm multiplying that by v naught, I don't know what v naught is, plus v, which is 0, divided by 2. So now what I'm going to do is I'm going to take my 2 and multiply it up here. So this becomes 80 meters. And then this top part, because this is 0, we don't have to worry about it. It just becomes 3 v naught. So to get my v naught isolated, I'm going to divide both sides by 3. And v naught becomes 26.7 meters per second. And that is my initial velocity. Thank you so much for listening. I will see you next time when we start talking about free fall, which is a subtopic of acceleration. Bye!